Hi, my name is Kleber. I'm from SCCs. In this presentation, I've been showing you the deployment of SAP application Azure in minutes. We will show some works that we have done with a customer here in Brazil, where we have automated some tasks running SAP application on Azure. Uh, I will give a brief introduction about the case, the company where we work, and next we'll talk about Terraform and Salt and how we have put these two pieces together. And next we show a demonstration about the deployment in Azure. And also you point some reference and materials that you share with the code that we have used during this work. First, I'm presenting myself. My name is Kleber. I'm the director at SCCs.
So hi, I'm Gabriel. We are from Brazil. Okay, SIS is a Brazilian company, and I work on SIS since the beginning. I'm also a founder of SSIS, and currently I work directly with the operations team in technology part of the company.
Perfect. First introduction about the company. SSCs is a SUSE Platinum partner for services and training. We have, together with SUSE in Brazil, many SUSE case with different topics of technology. We have expertise on Linux, monitoring, software automation, and software development in DevOps. And we have many SUSE certified professionals in our team. About the challenge that we present here, we were working on a project where we had to deploy SAP infrastructure using high availability stack, and we had a short time of 40 days of a project since the start of the project and now servers going live, and you have all the load, all the data being loaded in those servers. So we as we have around 40 days of project, we have 15 days to deliver all the SAP systems because we have to forward those systems for other SAP professionals to continue with the load of data and validations. So we have to deliver all systems with the registrations, updates, all applications installed, all SAP customizations applied, security baseline applied, and also all the high availability also working. So in terms of numbers, we delivered 6 SAP ASCS servers and ARS clusters in this project. So we started thinking about how we could automate and how we could improve the deployment of those servers for this project. So in the next slide, we started studying how the salt formulas from SUSE for AJ SAP Terraform's deployment works, but we found that some of the aspects of the project could not be covered by this code because the customer needed to make use of NetApp files on the Azure. And we also try not to use the public IP on those servers because this Terraform's automation requires that you have public access because you need to use an SSH connection to make some of the customization that is needed in the virtual machines. So As we need to create very custom in our perspective infrastructure, we started Terraform's template from the ground to validate all the aspects of this project. And we added some features that is not available today in the Terraform's deployment from SUSE. That was the support for NetApp files. And we use a different approach for the configuration of the servers. We started using the cloud init to run post setup and configuration of the instances. And we made usage of Azure storage for mounting as SAP medias for the installation of the software stack. First of all, talk a little bit more about Terraforms. Terraforms implement the concept of infrastructure as a code so that we can create an infrastructure based in a high level description file. Our project was based on Azure, so we use the components and a piece of code from Terraform that are specific for Azure. We created all the components in Terraforms. We use all the components Terraforms to instantiate our SAP instances and made all the configuration that is needed for the application to run smoothly, since creating resource groups, subnets, the virtual machines in C, load balancers, Azure AD applications, etc. One of the key benefits that we have with Terraforms is that we can check. We have many aspects of validation in the deployment of the infrastructure. So Terraforms can validate the configurations that we did. All the objects that are instantiated in the Azure are keep it by the Terraform, so that in our case, we have some configurations, for example, in network security groups, when we have a network security group existing in the infrastructure, so we can add roles inside of it, and when we destroy the infrastructure, the network security group is preserved. Only the roles that was added by Terraforms are removed. And we created, we used an approach available in Terraforms for Azure that was creating a custom cloud init. So that we created this custom cloud init on new machines. And this cloud init is responsible for making all the adjustment in this virtual machine, makes registration if needed, doing configurations of package, pillars, salt, etc. During the configuration of the instance in Azure, we made the usage of the SUSE sort formulas using the concept of masterless minions, so that all the configuration are running only locally. We point here the formulas that we have used during the project, because we also deployment the HANA Bootstrap to be used by the ASCS application. And on the next slide, we have an excerpt from the terraform.tf-vars file. In this file, we have all the definitions about the deployment of SAP in high availability. So we can fill all the fields with information of our infrastructure. For example, subscriptions, tenant and secrets, informations about network security groups, about storage that to be used, about load balancing, about ASCS, about ARS, about passwords that to be used, about HANA informations, In the next, we have also informations about the load balancers, about the virtual machines that will be instantiated, and also informations about uh, um, the fencing object from Azure that we have used, and NetApp files definitions. In this work, you have added some features that we, in our understanding, cover all the documentation that is available from SUSE and Microsoft, so that we had implemented the features on Azure for availability sets, proximity placement group, cloud init template files to include our custom code. We have used the feature of Azure AD enterprise application so that we created a custom application in Azure that will be used for fencing the virtual machines in scenarios like high availability when we need to avoid stonage problems, all the roles that are necessary for allowing this application to fencing the virtual machines, all the roles related to network security groups, mounting points for mounting SAP medias, uh, the storage for NetApp files that will be used for SAP, and also the added supported for uh, under reading events, schedule events from Azure. This point is important because in case Azure has any event about downtime of servers, the PC Maker component, you be notified by this component, and you migrate the resource in the cluster for another node. During our tests in using the component for Stonage, we discovered that the fence Azure ARM fencing that is responsible for uh, guaranteed integrity of instances in high availability in Azure was not working. We made some researches about that to understand what was the source of the problem. And with the last updates on Azure SDK, after the 15 version in the Azure Management Resource component, the code as is not working. So we made some resources, and we were able to figure out the points that we need to change to make this resource work again. Um, and for it, we also needed to install the Azure Identity component to in those systems, and we have made dispatch available so that it could be used by other people with this kind of scenario. Um, as a next step of our work, we you evaluate the other points that need to be changed in this component, and communicate with the community so that this change could be uh, 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 made available upstream too. Uh, the other part that we needed to change was related to defense injury arm uh, uh, binary, where you need to change the way the status of power off is understood by Azure. Also, this problem is related to the upgrade in Azure SDK. It also dispatch is available. And all this code that we are showing here will be available in the GitHub so that the community can contribute or make any comments on the work that we did.
So it's important to mention that we will submit those codes as a patch for the communities that run the project. And when this when this gets available, we also don't need to patch those codes on the Cloud Niche startup. So I will talk about the automation steps that we make for our environment. So on the first part, we used Terraform to launch machines and the security groups and the subnets and all the infrastructure necessary to put up this cluster. And then we used an automation on inside Cloud Init. So we created a script that makes some calls to get the environment done inside each machine. So this is the steps that this script takes on Cloud Init. So for first, we enable swap disk, and then we get the variables enable the variables inside Terraform to register those machines on SUSE with customer registration code, and then we can update all the system and also install the packages necessary for SAP. So later we can use one Azure storage with SAP Media to get the system done to start the installation. So today we patch the codes that we encountered some problems. We also patch some states on SUSE formulas because we are using a new version of Salt, and we also will push this as pull requests on SUSE repositories. And later we can configure Salt Medium to run locally on the machine and encounter the new pillars that we are pushing inside the machine. And we populate the pillars with templates inside this script using the Terraform variables. And the latest steps is to install the SAP components. And for the final step, we used some kind of template using the variables provided by Terraform to create the cluster configuration for these components installed. So let's for these steps we run on those times. So for the infrastructure part, for the Terraform deploying in Azure, we get some 5 minutes to deploy the ASCS and the key replication machine and all the infrastructure needed by this environment. So later on the part of Cloud Init that get the machine done to install SAP, we get some timing like 12 minutes. And later we have 40 minutes to install all the stack. And we have a total of 31 minutes to get the Kiwi part for SAP done. And we need to run only one command inside the machine, outside the machine. We only run Terraform apply and get all the things done. Okay, so let's jump into the code. Of course, we cannot run a demonstration with 31 minutes here. So we run the code before the presentation, and we can show the code and some logs of this installation. And later we can see the components running inside the SUSE Hawk interface. Okay, so the first step is to get the the infrastructure done. So I can show these logs, or these are the resources that will be deployed in Azure, and also the variables here. And we can get on the top of the bash, and we can see only Terraform apply here. Okay. So later we log on those machines, on the provided machines, and we get some. We can look at the Cloud Init output file. Okay, so we can see all those steps of installation getting done. So we can we can see the repository being updated, the registration of the system, the update of packages, and also the installing the packages needed by SAP. Okay, and then later we can see the salt commands here and being executed, the pillars being rendered. Okay, and later salt will run on SUSE formulas and get the installation done. Okay, and at the final step, this code will deploy a configuration on the pacemaker. So this is the code. We have only to define these variables, of course, defining where these resources will be created on Azure, making getting some credentials here, and then we can define all the structured and variables here with the network name and password and location resource group. And then we define all the storage account that will be used for SAP media. Okay, the load balancer rules. We can set the network security rules. Here we are using a very very insecure subnet, but we can restrict the access inside the subnet, listing the ports that this security rule must apply in these machines. And we, in all steps, we can we use this kind of rule. You can use a definition of ports or of source address defined by a list. Okay. And then later we define the size of these machines. We define some variables. We define SAP variables, and also the paths for installation that will be mounted inside this storage account. Okay. So and we have one script to get the steps done. So in this script, we set up all the registration and install the packages needed, upgrade the system, define the credentials to mount HANA Media inside machine. And we also apply the patches. We can get rid of this when this code makes available on the next release of Azure Fence. And we also define some pillars for SUSE HA formulas, and also for SUSE and NetWeaver Bootstrap formulas. And then we run commands to apply those states using Salty locally. Okay. And also we define the cbconfig ruled by variables that we will define here. Okay. So we need to get this script on base 64 pattern, so we can specify the cloud need to run this code here. Okay, we put the base 64 code of this script here, and also we pass the variables here because cloud need will use these as bash variables, getting things from here. Okay, so this is the code, and we can get take a look. We can take a look at the final result. So we have all the resources here: the IP, the listener for the load balancer, also the SAP resource, and also we have the fencing here working with Azure fence, not using SBD or something like that. And also we have the resource to listen for Azure events and get things migrated before any kind of maintenance on the hardware that that is running those machines. So this is our demo. We can get back to our slides here. So that's it. We would like to thank the Ronaldo Alves and Bruno Leonardo from Piracanjuba. Piracanjuba is the customer that allowed us to run this scenario and allowed us to create and test this automation on their environment. And also we would like to thank Carlos Mota from Microsoft. Carlos Mota was responsible to getting some accounts that we can run all this code and also gets help to use NetApp resources inside this lab environment. So all this code is available at GitHub. So feel free to get a fork or make a pull request to us, and feel free to contribute with this code. Okay, so this is the reference that you use it to deploy to develop this automation, and that's it. Thanks for watching. Feel free to reach us if you have some doubt. We are open to collaboration and also for suggestions to improve our code. Thank you.